Thank you. So what we've been doing so far is using information given to determine what the graph will look like when we sketch it, without plotting to scale, of course. So for example, you are provided with the vertex. From the vertex, you are able to know that if one root is here, this is the other root. You are provided with discriminants. You can know, okay, it is positive definite, it's negative definite, it's going to touch, it's going to cross, and you are able to sketch. Does that make sense? In this, with this next thing we are going to do, the sketch has been given. So it is now for you to bring out what should have been the equation. Y is equal to ax squared plus bx plus c. Do you understand? So it's more or less the reverse of what you've been doing the last 2 or 3 lessons. And that's what we want to combine in one lesson. Okay? Or fraction of a lesson. Okay. Here is a problem. We want to find the equation of this graph. Look at the A part. There is the y-intercept given. There are 2 roots of the equation, if that was an equation. Okay? It crosses at 2 points. So something tells you, okay, look at this, everyone. You have ax squared plus bx plus c. Yeah? The fact that it crosses, you don't need to start with this format. Because it crosses, definitely is of this form. Remember your investigation? Because it crosses. The one that touches must have been of this form. So this is where you begin. Crosses means this. Touches means this. Are you with me?
Yeah.
Now, your P and Q are there. Melody, what is P and Q from picture? What A? Speak louder, please. What is P and Q for A?
-1 and 3.
Does everybody agree with that?
Wait, 1.
Say that again.
1 and negative.
1 and negative 3 is of the opposite sign. Because when this is solved, you get the opposite of P outside. Does everybody understand what I mean by that? Or do I need to explain everything in detail?
Yes.
Raise your hand if you understand what I mean by that. Okay, great. So if the answer is -1, it must have been +1 inside the bracket. So that tells you the quadratic you are looking for is more or less x plus 1 and x plus 3. Y is equal to? Minus 3. Oh, my bad. Sorry, I know my teaching is not normal. I hope we can still cope with my laziness today. Okay, so we have that. Who can tell me why A is significant? Why can't I just say, oh, the equation is going to be x plus 1 and x minus 3? After all, this is positive too. Yes, sir.
The y-intercept.
The y-intercept needs to be taken into consideration. If you do this, the y-intercept is -3. Do you agree? Because when you expand the bracket, -3 is the constant, right? But is that -3? No. Does that make sense? And here, A is positive. A is positive means it should have been this way, right?
Yeah.
But the graph is that way. So A is not determined until you know the exact value. You don't assume that it's going to be. So this is why your format will be in this form. This is why you recall your investigation. And in the investigation, we did 3 different things, I think. This is the first one. The second one, we talked about the one that never touches as well. Understand, please? So your beginning is to see, what does the picture tell you? Is it the one that crosses at 2 points? You start from here. If you know the 2 roots, of course, you supply them. Okay? And you use your intercept. Intercept 3 means when x is equal to 0, y is equal to 3. You put that here. When x is equal to 0, you get 1. Here you get -3. Your A is still there. Y is equal to 3, you get this one. This is how you figure out your A. And once you figure out your A, your quadratic is figured out as well. Similarly here, your P is 2. Agree?
Yeah.
Your p is 2. So this is more or less y equals to x minus 2 all squared with a waiting for you. And because you also have the y-intercept, you substitute. When x got to 0, y is equal to 8. 0 minus 2 is 2, so this is negative 2 squared. Does that make sense? And again, a is deduced, and once you get your a, which I think is 2, right? Then you can say, oh, therefore the graph is 2, like that. Understand? And there's another example on vertex. So please listen to this. You might get additional information from the audio part of it. This is what I would have worked on the board, but I'm not so...
If we are given sufficient information about the graph of a quadratic, we can use the information to determine its equation. For the graph given in part A, the x-intercepts are -1 and 3. The x-intercept -1 corresponds to the linear factor x plus 1, and the x-intercept 3 corresponds to the linear factor x minus 3. However, we do not know what constant these factors are multiplied by, so we call it a. We now have a general equation that describes all quadratics that have the x-intercept -1 and 3. The graph is concave down, so a must be negative. To find the exact value of a, we need another piece of information from the graph. We see that the y-intercept is 3, so the point 0, 3 lies on the graph. This point must satisfy our general equation. We substitute x equals 0 and y equals 3 into the equation and simplify to find a equals -1. We now have the equation of the quadratic. In part B, we see that the graph only touches the x-axis at x equals 2. This tells us that x minus 2 is a factor of the quadratic, and in fact is a perfect square factor. Any other factor of this quadratic must be a constant, which we call a. We now have a general equation for all quadratics that touch the x-axis at x equals 2. The graph is concave up, so a must be positive. To find the exact value of a, we use the y-intercept. Since the y-intercept is 8, the point 0, 8 lies on the graph. We substitute x equals 0 and y equals 8 into the equation and simplify to find a equals 2. We now have the equation of the quadratic.
Does this make sense? Now, just so you know, this is just for information's sake. You don't have to include it. Okay? But you can see the shape of the graph. You know that your a is definitely less than 0. So if you come here and you get a to be 3, then you know something is wrong, because that is not what it should be. So that's the information. You don't have to include it in your solution. That's the point I'm making. Understand? Because the question is not about find the curvature, tell us the shape of the graph. The question is find the equation. So if you don't talk about a less than 0, it has to be concave downward, it's immaterial. If you include it, no problem. If you don't include it, no problem. One more example, so you can get this done. I think 2 more actually. 2 more examples, so let's quickly do this. So this is another one. In this case, you are given the equation of the line of symmetry instead of the additional information. And we have talked about this. Let me just give you let me give you something about this. You can also link this kind of question to the previous one. It touches at 2 points, crosses at 2 points, which means it's of this form, right? But you don't have the second one. You can tell me something that we observed in the past, not you. Let's try someone else to figure out the second one. Yes?
The line from the axis of symmetry to the point.
So there's a symmetry. Thank you, Carolina. So whatever distance you have here is the exact distance you have here. Right? So what is the gap from here to here? 3. So this must be 4. So now it looks like the first example. Does that make sense? So let's listen to that.
The graph of this quadratic shows the y-intercept, one x-intercept, and the axis of symmetry. This gives us enough information to determine the function. It would be useful to know the other x-intercept, so we could write down the factors of the quadratic. Now, the axis of symmetry lies midway between the x-intercepts. The x-intercept minus 2 lies 3 units left of the axis of symmetry, so the other x-intercept must lie 3 units right of the axis of symmetry. The other x-intercept is 4. The x-intercept minus 2 gives us the factor x plus 2. The x-intercept 4 gives us the factor x minus 4. We multiply these factors by a non-zero constant a to obtain the general form for all quadratics with x-intercepts minus 2 and 4. Using the y-intercept, the point 0, 16 lies on the graph. It must satisfy our equation. We substitute x equals 0 and y equals 16 and simplify to find a equals minus 2. We now have the equation of the quadratic.
Okay? So the only idea here is that symmetry that we all remember. Okay? Now, the last one. What if you do not have the shape, but rather you have information? Find the equation of the quadratic, which cuts x-axis at this point and passes through this point. Again, it cuts at 2 points. Then you know it is of the form ax minus ps minus q. Understand? You substitute those 2 points. The reason for giving you the y-intercept is to be able to find what? Denise. In the previous example, you were given y-intercept, right? Can you tell me the reason why the y-intercept is important? To find a. But does it have to be y-intercept? It doesn't have to be. You just need, when x is equal to this, y is equal to that. Which means you need a point that it passes through. Any point on the graph. Understand? You have your curve. You have your x to y intercept. Your y-intercept is here. If the y-intercept is not given, but this point is given, it works. If you know these two already, the only thing left is to find the value of a. And to find the value of a, you need to know when x is equal to this, what is y is equal to that, and that gives you the value of a. And that is what you have in this. But then they went ahead to say put it in this form, then you can expand. Understand? So let's see.
In this question, we are given information in words. It may be useful to sketch a graph with the information, but you do not necessarily have to do this.
I'll recommend this sketch.
We are given the x-intercepts 4 and minus 3, and that the quadratic passes through 2 minus 20. The x-intercept 4 gives the linear factor x minus 4. The x-intercept minus 3 gives the linear factor x plus 3. Multiplying these factors by the non-zero constant a gives us the general form for all quadratics that have x-intercepts 4 and minus 3. Since the point 2 minus 20 lies on the quadratic, it must satisfy our general equation. We substitute x equals 2 and y equals minus 20 and simplify to find a equals 2. We are asked to give our answer in general form for a quadratic function. So, we take our quadratic in factored form, expand the brackets, and then apply the distributive law.
Okay? So just expand and that's it. Any questions? All right, so I'll give you this. It's a 4-page worksheet. Hand it back to me next week. All right? And let's fix a day for some tests. So I'm going to give you about, because it's time to wrap up the term, and give ourselves some evaluation and see what we have done, right or wrong. So I'll give you some tests based on some topics we haven't done. So how about we list some of the things we have done so we can have different days, maybe like 2 days, one on Tuesday, one on Thursday, or one on Tuesday, one on Wednesday, something like that. I think maybe we can turn this off first so we don't record our test conversation. We don't need that.